Swayam Prabha. Digital India. Educated India.
Okay. So, we have discussed the two, we have derived the two equations, equation of state and equation of mass. Now, we go for the derive the equation of force. We draw the same things, that same volume we consider, that same volume we consider in the propagation space of the wave, and the medium is liquid. We have considered this is nothing but a dx, dy and dz. Okay. So, I consider that same volume I consider. Now, equation of force. What is the equation of force? It is nothing but a Newton's second law of motion. The force is equal to mass into acceleration. So, what is force? I said when that acoustics were propagated in a medium. So, if this is the plane, this plane will expose to a pressure. Let us the wave is propagated in this direction. So, I am saying that pressure is acting on this direction. So, I can say Px is the pressure, total pressure acting on x direction. So, total pressure is nothing but a total pressure minus equilibrium pressure will be the acoustic pressure. So, I said total pressure acting on this surface is Px. So, what is the force? What is the definition of a pressure? Force per unit area is the pressure. So, what is the area of this plane? Nothing but a dy into dz. So, force acting on this plane is nothing but a Px into dy dz. So, force is pressure multiplied by the area. Now, if force is propagated in this direction, pressure is propagated in direction. So, I also this here also will be some pressure, this boundary also some pressure, this surface has a pressure and that opposite surface also experiences some pressure. So, that pressure is nothing but a, we said Px is the pressure in here, change of pressure plus Px plus change of pressure means del Px by del x. Change of pressure in x direction multiply by the distance dx, because I have to travel from here to here is dx distance, and rate of change of pressure in x direction is del Px by del x. So, the pressure in this boundary will be here, and also it will be multiplied by the area, same area will give me the force acting on this plane. So, if the direction of the force is this way, so net amount of force inside this volume will be this force minus this force. So, net amount of force del Fx acting on x direction is nothing but a Px minus Px plus del Px by del x into dx whole multiply by dy dz. Area is multiplied by the area is the force. So, if I derived it, it is minus del Px by del x into dx dy dz. So, it is nothing but a minus del Px by del x into del v volume. Px, Py, Pz is nothing but a volume. Okay. Similarly, I can get del Fy is equal to minus del Py divided by del y into dv. I get del z, del Fz is nothing but a minus del Pz divided by del z into dz, into del v. Similarly, y direction and x direction all direction will get. So, what total force acting on this volume in all three directions. So, will be is nothing but a summation of those things. So, what total force is nothing but a del F, or I can write del dF is equal to del Fx dFx dFy plus dFz. So, it is nothing but a minus del Px by del x plus del Py by del y plus del Pz by del z into dV. Very simple. Okay, into dV. Now, if you see, so what is this? Del Px del y, del Px del x, del Py del y, del Pz del z, nothing but a divergence. So, I can write minus divergent of P into dV, minus divergence of P into dV. Okay. Now, if this is a volume on an acoustic plane, let us this is a whole thing is a liquid. So, in liquid this is the volume. So, this volume not only exposed to the pressure force, but also exposed to the gravitational force. So, gravitational force will only work this way. If I consider the volume in here, so there is a gravitational force, G will be there. Okay. So, what is the gravitational force? Total force is nothing but a this force plus gravitational force. What is the gravitational force? We know G into mass, gravitational acceleration into mass is the force. F is equal to A into F, A into M into M into A. So, gravitational acceleration plus mass. What is the mass? Rho into dV is the mass. Gm is the gravitational force. Okay. So, this is the total force acting on this volume. Okay. Now, if I apply a force on a particle, what will happen? The particle will move. So, I expose a particle, I expect a particle velocity in here. Okay. So, let us particle velocity is u, it will be on all three directions. So, u is a function of x, y, z and t. Particle velocity can vary with the position of the particle and also with respect to time. So, Pu is a function of x, y, z and t. Now, if I consider, let us this is ut and another time I take ut plus del t or dt, we will write, always we write dt. After little change of time, not only time change of the particle, the position of the particle also change. Position of the particle also change. So, here this, if this is my initial ut, after dt time I will get a particle velocity which is u x plus dx, x plus dx, y plus dx, z plus dx, dz, sorry dy and t plus dt. If the particle change with respect to time, particle velocity u is a function of x, y, z, t. If t change, then x, y, z also change. So, I at the t equal to t plus dt, I will get a new particle velocity which is u x plus dx. Let us dx is a change x direction, y direction change is dy and z direction change is dz. So, new u is nothing but a u x plus dx, u plus dy plus dz. Okay. Now, if I express new things, new particle velocity in term of Taylor expansion, because of the del t time is change. So, it is nothing but a, so I can write I can write that u x plus dx, y plus dy plus z plus dz and t plus dt is nothing but a initial u x y z t plus change due to x direction. So, change of u in x direction del u du. So, change in x direction is del u by del x into dx. Change of u in x direction plus change of u in y direction plus change of u in z direction plus change of u due to time. So, del u by del t into dt. I can write this thing. So, u initial velocity plus change of velocity due to x direction, due to y direction, due to z direction and due to time. Sorry. Okay. So, now if you see in this equation, so what is dx? What is u? Ux is the velocity in x direction. So, ux is nothing but a dx by dt, change of displacement per time, rate of change of displacement is equal to the velocity. So, that del x is nothing but a, or dx is nothing but a ux into dt. Similarly, dy is nothing but a uy into dt, dz is nothing but a uz into dt. Okay. So, I put that things in equation. So, that equation becomes u x y z t plus dx is nothing but a ux dt. So, I write del u by del x into ux dt plus del u by del y into uy dt. So, this will be y, sorry, this is all, or you write in u dt plus del u by del z into uz dt plus du by dt in del t into dt. So, dt is common, dt is common. So, now I can write the same equation I can write. So, this will come u x plus del x dx, y plus dy, z plus dz, t plus dt minus this one u x y z t divided by dt is equal to del u by del x ux plus del u by del z del y uy plus del u by del z uz. Okay or not? Simple. In that case, what is this? Del u del x ux, okay, del u plus del u by del t, that term will be there. So, now I just deal with that this term. I am writing del u by del x into ux plus del u by del y into uy plus del u by del z into uz. Okay. What is this? What is u divergent? Is nothing but a ux del by del x, okay, plus uy del by del y plus uz del by del z. So, I can write this is nothing but a u divergent u. U divergent u is okay or not? Okay. Ux del x I consider, then I have du, I consider that things. So, it is nothing but a divergent of this thing. Now, so this is nothing but a, this is nothing but a one t term will be there, which is del u by del t plus u dot divergent into u. You just change this term and du dt term will be there, du dt term will be there. Okay. Now, what is this? It is a del t. Now, if I instead of del t, if I write delta t, instead of this I write delta t, then what will be there? There will be a limit delta t tends to 0, then it is dt. So, in limit t tends to 0, difference of velocity divided by the time is nothing but the acceleration. Rate of change of velocity is the acceleration. So, I can say a acceleration is equal to del u by del t plus u divergent u. Okay. That is the acceleration of the particle. Now, what is the force? Force is called mass into acceleration. Force is nothing but a mass into acceleration. So, if this is my acceleration, I have to multiply by the mass and I get the force. So, I can say total force dF is nothing but a acceleration into mass. What is the mass of this volume? Rho into dV. So, it is nothing but a into rho dV. If it is a into rho v dV, I can put the value of a in here. I can put the value of a in here. So, I get it is nothing but a del u by del t plus u divergent u multiply by rho dV. And what force expression I have we have derived? The expression of the force from that equation, we derived that del F total dF total force is nothing but a divergent minus divergent of total force into dV plus gravitational acceleration into density into volume dV. So, this and this must be equal, because force difference of the force which is acting on inside the volume will be same is produced by the particle acceleration inside the volume. So, if the particle acceleration is this multiplied by the mass is equal to the total force. So, total force is nothing but a force applied from all direction minus force exit from in all direction. So, in that case this and this must be equal. So, I can write that now I get the one equation. What is the equation? Equation I get minus P dV plus G into rho dV is equal to del u by del t plus u divergent u whole multiply by rho into dV. So, I can say that dV all both side dV will be cancelled, dV will be not acting. So, I can cancel this dV. So, I get what is the equation? Minus del P total pressure plus 0 is equal to del u by del t plus u divergent u whole multiply by the rho. Okay. Now, think about if there is no acoustic pressure. No acoustic pressure means total pressure is equal to P0. Okay. So, which force is applied only? Gravitational force. So, at equilibrium condition, when there is no acoustic excitation is injected, the acoustic excitation is 0, then only the gravitational force is acting. Okay. So, if I see this equation in this equation, if I say there is no acoustic excitation, no acoustic excitation, in that case I can say that G rho 0, no acoustic excitation means density in equilibrium density. So, rho 0, G rho 0 is nothing but a equal to divergent of P 0, because this portion is 0. No particle velocity with respect to time and with respect to position, no acoustic pressure. I have said that there is no acoustic force is applied. So, I can say the gravitational force only applied will be there. So, G into rho 0, because at no excitation, so rho is nothing but a rho 0 is equal to divergent of equilibrium pressure. Okay or not? Okay. So, in that case, this is okay. So, what I will get in that equation? So, G 0 rho 0 is nothing but a del rho 0. Okay. So, the total pressure del P is equal to small del P more small p plus G rho 0. At when the acoustic excitation is not there, I said gravitational force multiplied by the equilibrium density is equal to del rho 0. Okay, gravitational force. So, what I said that del P is the total pressure. Del P is nothing but a del P minus del rho 0, del P 0. What is that? Nothing but a del small p. Let small p write like this way, small p. Equilibrium pressure, instantaneous pressure minus equilibrium pressure is equal to the acoustic pressure. Okay. So, if there is no acoustic excitation, then I say G rho 0 is nothing but a del rho 0. So, in that case, I can write equilibrium pressure, this del capital P is nothing but a del P 0 plus acoustic pressure. Is okay or not? From this equation, I can write total pressure is nothing but a equilibrium pressure plus acoustic pressure. Okay. So, if I put this thing in this equation, so I can write del P 0 plus acoustic pressure. Acoustic pressure is small p. Okay. Minus. This will be minus, this will be minus. I am just writing the total pressure is nothing but equilibrium pressure plus acoustic pressure. So, if I take the minus outside, so it will be minus, minus here and minus here, both is minus. What I said at plus Gp is equal to this thing. Okay. Now, I said that at there is no acoustic pressure, then del P0 is nothing but a G rho 0. So, del P0 is nothing but a minus G rho 0, G rho 0. So, it is nothing but a, this equation is nothing but a acoustic pressure small p plus minus G rho 0 plus Gp 0 is equal to same thing. Okay. So, G rho 0, Gp 0 0, 0 and 0 0. So, if I consider is a G is plus, so if I say that this is nothing but a plus G rho minus rho 0. G is common, rho minus rho 0 is equal to same things. Okay. Now, G rho minus rho 0, if I divided both sides by rho 0, what will happen? Both sides I divided, so I can write the my equation is become, I said acoustic pressure minus acoustic pressure plus G into rho minus rho 0 is equal to del U by del T plus U divergent into U into rho. Is okay or not? Is okay? Now, I divided by 1 by rho 0 both sides. Rho 0, P by rho 0. Is okay? So, see that G, this is G into rho minus rho 0 by rho 0 is what? Condensation. So, it is nothing but a minus 1 by rho 0 into acoustic pressure plus G into S. Condensation G into S is equal to del U by del T plus U divergent U whole rho by rho 0. What is rho by rho 0 in term of S? What is S? S is nothing but a rho minus rho 0 divided by rho 0. Okay. So, rho by rho 0 is nothing but a 1 plus S. 1 plus S. So, I write 1 plus S. Condensation 1 plus small s. Now, consider the limitation. What are the limitation I said? Now, I have to, so there is a term I have defined. Now, I consider the limitation. What is limitation? We said G into S, the amplitude of G into this since it is a vectors, so amplitude of G into S, let us consider very less than the del P by del rho 0. That means, the amplitude of this term del P by del rho 0, acoustic pressure by rho 0 compared to Gs, Gs is very less compared to this term. So, I can ignore Gs because S is less than 1, always S is less than 1, rho minus rho 0 divided by rho 0. So, it is A is less than 1. So, it is if it is less than 1, then I can consider G into S is a very weak term compared to this term. So, this term I can ignore. I can ignore this term. Similarly, if I consider the amplitude of this vector, this vector's amplitude, this vector amplitude is much less than this term. Then I consider this term is nothing but a 1 by rho 0 minus into divergent of P is equal to nothing but a del U by del T. Okay. So, S is, I am considering S is negligible because it is much less than 1. Gs is negligible compared to this term and this term is negligible compared to this term. Why I consider that thing? See that what is G into S? Condensation multiply the acoustics, the gravitational acceleration. Now, if S is very smaller compared to less than 1. So, this term is very small compared to change of pressure due to the position divided by rho 0, and this term, what is this term? This term is divergent of particle velocity, means rate of change of particle velocity in all three directions. Okay. So, with respect to time, I said the positional change is very less, positional change not displacement, rate of change of velocity is very less. In that case, I get minus 1 by rho 0 into divergent of acoustic pressure is equal to differentiation of that acoustics. So, I can write, or I can write rho 0 into del u by del t is nothing but a divergent of acoustic pressure. So, it is not total pressure, it is acoustic pressure, small p, because we have considered that things del 0 that we have derived. So, I get acoustic pressure is a function of acoustic velocity with respect to time. So, this is called force equation, sometimes it is called Euler's equation or force equation. So, I get equation of state, I get equation of continuity, and I get equation of force. So, these three equations if I write, what are the three equations? I get three equations: acoustics of state, acoustics of continuity, equation of continuity, and equation of force. So, equation of state, P is equal to B into S. P is the acoustic pressure, small p, that I get B into S, and another continuity del P by del T plus divergent of rho u is equal to 0, that I get from the second acoustic, and from the force equation I get rho 0 into del u by del t is equal to minus p. Now, what I want? I want linear wave equation. So, wave equation for what? Wave equation of acoustic pressure. So, what I get? How do I get the acoustic pressure wave equation? So, pressure is a function of position and time. So, pressure is a function of x, y, z and t. So, I should get an equation, pressure is a function of position is equal to some function of time. Okay. Now, if I take the only, see that this equation rho 0 del u by del t minus del p, this equation of force. If I take the divergent in both sides, so I get divergent rho 0 del u by del t is equal to minus, okay or not? Take the divergent both sides. What is this del square called? Del square called 3-dimensional Laplacian operator. It is nothing but a d2x by dx plus d square by dx plus d square by dy plus d square by dz square. So, that is the Laplacian operator. So, Laplacian operator is nothing but a dx square plus dy square plus del square by del z square. That is I get. Instead of rho, I use in term of condensation. Okay. Now, if I take the time derivative of this equation, what I will get? I just take the time derivative of this equation, both side time derivative. So, I get rho 0 del square s by dt square, d square s by del square s by del d square, del t square plus rho 0 del u by del t is equal to 0. Is okay or not? I taking the time derivative in both of this equation. So, now if you see rho 0 del u del this term and this term are same. So, I can write rho 0 del square s by del t square is equal to minus divergence square of p. Okay. Or here I can write the divergence square of p is nothing but a minus, or minus will be not there. There will be minus, or minus will be not there. This term is same. So, this term will be, this term is nothing minus. So, minus will be not there, because this term is equal to minus. I put the minus del square p. So, it will, that side will be plus. So, it is nothing but a del square p. So, del square p is nothing but a rho 0 del square s by del t square. Okay. Now, what I get? I know p is equal to Bs. P is equal to Bs. What is S? P by. So, instead of S, rho 0 del square p by del t square by b. Okay. So, what is C? C is nothing but a, we said, bulk modulus divided by density. So, bulk modulus divided by density is 1 by C. So, it is nothing but a C square is equal to bulk modulus divided by density. So, it is nothing but a 1 by C square del P by del T square. So, the wave equation, ultimately we have derived that type P is equal to 1 by C square del square P del P by del square P by del T square. I have derived that wave equation. So, this is called linear wave equation. Linear wave equation. Okay.